I'm Max Saltonstall. Welcome to Architecting with Google Cloud. Have you ever wanted to know how those ads end up inside your mobile apps, inviting you to install something else? How does machine learning work to figure out which ones are the right ones to show? I was pretty curious, so I invited Chang, VP of Engineering at Moloco, to join us. Hi Chang, welcome to the show.
Hi Max, thank you. I'm happy to be here.
Can you tell me a little bit about Moloco and what your role is?
Moloco is a startup, and then we want to build and deliver the world's best vertical cloud service for online advertisement and marketing businesses by helping them unleash their data or the power of their data using our AI and big data processing technologies.
So I'm using an app on my phone. I see an ad inviting me to install something else. Can you walk me through the life cycle of how that ad gets through all of these systems and ends up on my screen?
We'll start working with our customers who are typically mobile app development companies, and then their marketing teams come to us and then commission their advertisement campaigns because they wanted to sell their apps or have more people use their apps, install their apps, engage with their apps, and so on. So that's their key goal that they achieve through Moloco. And when we receive these ad campaigns, on the other hand, we have lots of mobile users out there, right, around the world, billions of users using, phones or typically similar kind of form factors, tablets and so on. So whenever they use their devices, some apps are running, and then these apps keep creating the advertisement slots. So these are called ad spaces or ad inventories. And then we basically want to fill these ad inventories by showing them the most relevant and helpful advertisement contents to them. And to do that, we need some matchmaking. And then this matchmaking is done through what we call the advertisement exchanges or ad exchanges. These are similar to the stock exchanges like NYSE and NASDAQ, where supply and demand meet together and then arrive at the right outcomes through online bidding. We receive these ad inventories not directly but through ad exchanges, and then whenever we receive this bid request, we quickly evaluate the value of this ad space relative to our advertisement customers' campaigns, and then we use a lot of big data and machine learning technologies to make a decision on whether we should participate in that bidding or we should not. And then if we're going to participate, at what price should we bid for, right? So we make these quick computations and decisions. And then when we respond, again, back to the ad exchanges, the exchanges collect this information and then run the auction, online auction. And then if we happen to win, then we own that particular ad space that is created at that point, and then we show our customers' ads through that space. So the unique thing about this industry and using ML for this industry is that we have to come up with quality inference result, but very timely as well, because think about the stock exchange, right? When you announce that there is this supply, the demand has to make a bid very quickly. In an online ad, it's the time, the stringiness of the time is actually even harsher, because when you open a publishing app, that ad slot doesn't wait for you forever. It's usually, gonna wait for, say, about 100 millisecond or 150 millisecond. Within that or after that, the proper ads need to show up. Otherwise, it's considered a failure. So when we receive this bid request through the ad exchanges, we have to make that decision very quickly, typically within 100 millisecond. And then that 100 millisecond includes networking latency and our other infrastructure latencies as well. So the actual amount of time that is left for ML inference is actually even smaller. It's typically about 20 milliseconds or even less sometimes. So, but still we have to make a very relevant predictions about this particular user and the content. So, and also we have to use many ML models, not just one, because we have to guess the user's interest level about these campaigns, many campaigns, and then we have to predict how likely the user is going to use this app, or they respond to the advertisement and then use the new app over time, and then create even more lifetime value. We also have to predict the market conditions at that point in time, because everything keeps changing, so that we can derive the right bid price as well. So all these models need to work together, sometimes in tandem, and then we still have to meet the 20 millisecond latency. So that's the crux of technical challenge that we're dealing with. And so we use a few, we learned a few lessons by working in this industry long enough and then creating values. So for example, we are using a relatively shallow DNN models. So it's not that deep, and we realize that unlike natural language processing or image processing, these inferences that we make for this advertisement businesses doesn't need to be that deep, but we still use a lot of features. So it's shallow but very, very wide models that we use. And it's okay for us to spend a lot more time and resources for training these big but shallow models, but the inference needs to be done very quickly. That's why we're using shallow models. We're using a lot of other big data processing technologies to reduce our response time as much as possible, but I guess that probably requires another session.
Wow, those are some impressive numbers. At least I think they are. Was it a challenge building something to handle all that? How did you scale up?
Yeah, so the scale is indeed a big challenge here as well. So the number of bid requests that we receive from the ad exchanges, that's already astounding, because we're receiving multi-million requests every second, which leads up to about 300 billion requests every single day. Compared to what NICE deals with, for example, they handle about 2.4 transactions every single day. We're already 2 orders of magnitude larger than that. So you can imagine how big and large this infrastructure is in general. And that's because the phones are just pervasive. It's just so ingrained with our lives, and then there's so many people using this all the time. So we're really handling huge scale. For example, like more than 10 billion devices reach it through our system every month. We're actually serving the ad inventories coming out of about 3 million unique publishing apps. We're doing our ad campaigns over 250 countries around the world. And then the number of ad impressions, the actual advertisement shown to the end users, that's more than 20 billion impressions every month. And then every single second, we're actually running more than 15 million model inferences. So this scale is the biggest challenge, along with the strict time latency that we have to abide by as well.
So 2 really big challenges. You've got a latency challenge. You have to make a lot of responses very, very quickly. And you have a big data challenge, creating and processing all of that data every day for your data science and machine learning pipelines. Wow. I am really excited to dive into the architecture of all of this. How did you make the magic of ad serving happen with all of that data on top of Google Cloud?
Receive advertisement campaign commissions from our advertisers through directly, through the front end or through API. We receive their request, and then we create internally this thing called campaign data structures, along with the actual creatives that the customers created to show their end customers or the device users. And creatives are really, the image files or video files or the text that are shown as part of the advertisement, right? So this builds the core campaign structure. And then these are stored on data store, Google managed data store system, because this requires SQL-like access as well. And then on the other end, we keep receiving these bid requests, huge number of bid requests through the ad exchanges. So we have a dedicated system called the bid processor. It's running on top of GKE, and then at the peak, we run, thousands of containers per region to keep sustaining this input rates. So when we receive this bid processor, each bid, we then need to choose a few campaigns or large number of campaigns that we need to evaluate against. Basically, we need to make a decision. Hey, for this bid request, basically for this particular user using this device at this point in time with this kind of contents and context, which of our campaigns are good matches. So we have to do that prediction using machine learning technologies. So that's done through our custom TensorFlow serving infrastructure running on top of the GK containers as well. Then when you run this model inference, of course you need to extract a lot of data about the user and then the current status of the user, which we call context information, and the user's profile. That's all public information collected through various channels. And then our previous bid history, because the chances that we might have served this user for our campaigns many times before. So we wanted to learn from our previous bidding histories as well. So we collect all this data stored in BigTable and BigQuery. So we read these things out from BigTable and BigQuery very fast, and then handle some of these things, process them, and then turn them into the right feature set for machine learning models, and then feed them into the TensorFlow serving. Okay, so that's what's happening at the bid time, and then when we decide to respond to the bid request, we generate a bid response and then send it back to the ad exchanges. Now, when we win this, the exchanges let us know that, okay, now you won this ad spot, why don't you actually show the result? So the result is shown through the CDN service. And then when the user, the mobile phone user actually responds to this, the response signals also come directly sometimes to us or sometimes through these umpires, as I mentioned, the MMPs. So these impression signals, click signals, and further engagement signals are collected and then come back to us. And then we collect all these signals through our notification processors and event processors. These are important not just because we need to properly generate our billing record for our customers, but also to collect the data so that we can keep training our models. Right? All these transactions that we do are just great training examples for our models. So that's really critical infrastructure again, collecting this feedback, and then we have to keep these things in the safe place. So we use BigTable again a lot, and then BigQuery a lot for that.
So it seems like that bid processor is sure doing a lot of work. How big is the Kubernetes cluster that you need to run, and how did you make it scale?
Good question. The short answer is we're relying on purely just GKE scaling feature set. Our bid processor is the biggest set of containers. Of course, we have many others, but let's just talk about the bid processor alone. It is using about 2.5K nodes at the peak time for processing incoming bid requests, and it keeps increasing. Our business grows, and then initially we started off with our in-house scaler system to manage the cluster for a while, but then recently we evaluated GKE's native scalers, a few of them, and then realized that just relying on strictly those is actually better now. So we're using just horizontal pod scaler and cluster autoscaler offered by GCP now.
Okay, let's talk about the data a little bit. You said 170 terabytes being generated every day. How do you store that, process that, use it for your training and analysis?
So we, as I said, we keep receiving this bid request and then all the follow-up signals from the ad exchanges about our bid results, and also directly from the mobile devices about the impressions and so on. So all this huge amount of data arrive again at our infrastructure through GCP's load balancer, and then we store them in BigTable. Sometimes the raw data in GCS, because sometimes we have to replay them, and then if it's very structured, and then if it needs to be handled by our data scientists, we also store some of them in BigQuery as well. So we're probably one of the biggest BigTable users of GCP right now. And all these raw data are stored here, scattered at various platforms. And then we read them out for two purposes. One, for training, and second, for analysis by human. Okay. So for training, we actually created a huge number of Dataflow jobs so that we can read these things out and then turn them into the machine learning feature sets, which we then feed into our Kubeflow running on our VMs. And then these are actually finally getting into, when we finish training our models, some models are trained hourly, some models daily, some models a little less frequently. But whenever we end up finishing our models properly, then we load them onto our custom TensorFlow serving infrastructure, which is integrated into our online bidding infrastructure, which I already explained. So that's one data flow part. And then the other part, our engineers and data scientists continuously need to look up this data to see whether we're heading in the right direction, whether we can improve something, or whether the market situation, the macro situation have changed significantly that warrants our model update or significant model redesigns or insertion of new models and so on. So that pipeline is typically done through the online analysis tools. We're a big user of Looker system, the Looker system as well. So Looker running on top of BigQuery is a big data processing pipeline for us as well.
And tell me more, how is Dataflow helping you move all of this data around, given the immense scale of your platform?
Yeah, Dataflow really reads data out of BigTable, BigQuery, and Google Cloud Storage, and then transform them into feature sets. The easy integration with BigTable and BigQuery was both in terms of read and write. That was a big or motivator for us to try this out. We run over 1,300 Dataflow jobs every day, and then process, as I said, more than 170 terabyte every single day. And the largest Dataflow job that we have currently uses up to about 7,000 virtual CPU hour per job, and so that's very CPU intensive. We also use Dataflow service-based shuffling a lot for performance gains these days too.
What led you to choose BigTable for storage?
It gives a very good latency and throughput at the same time. The key value reads and writes, over 10,000 QPS at less than a few or 6 or 7 milliseconds when we use especially SSD nodes. That's just so fast and scalable as well. We're handling about 220 megabytes per second. So the throughput is also great. And then the embedded garbage collection system or capability is also quite helpful because we can just automatically forget old data without worrying about or purging any of those things.
That is definitely a lot of data processing and a large number of requests. So how do you optimize all of this so that you can keep costs under control?
The challenge is that our scale keeps growing significantly, and yet your OPEX needs to be contained. So for example, last 2 years, our scale has grown more than 3x. So in terms of number of bid requests that we receive, as well as the number of bid responses that we generate, both more than 3x. So in terms of bid responses, we're now handling or generating more than 700 billion responses every single month. But we track, for example, our unit cost. So, for example, with $1 unit, how many bid responses are we able to generate? That's, for example, one metric that we use to measure our efficiency. So that cost efficiency has been sort of slightly going up last year. But then we realized that, we had to contain that. So we actually decided to spend a lot of engineering resources, optimization resources, by taking advantage of a lot of GCP capabilities as well. So it has started to come down, and it looks a little more stable now. And then some of the key technologies, GKE native scalers are helping us a lot because we can scale in and out very easily. And then we also now use more diverse types of nodes, even including preemptible VMs. So those things are all very helpful.
That's great. So why did you end up choosing Google Cloud for this platform that you built?
Pay-as-you-go pricing helped us bootstrap our business even when we were very, very small. Like we were able to, start growing our business very easily by just simply riding on top of very big and reliable general purpose cloud. Operationally, we also couldn't afford to have a big ops team. Our dev team had to just focus on delivering the right infrastructure code and then the right ML models and serving infra, training infra. So we started off with very lean operations team. Now we are a little bigger, but I would say that more than 70% of our operations are offloaded to the GCP team thanks to their capabilities and responsiveness. So that's always a big help. Stack Overflow is very helpful as well because GCP engineers regularly monitor it, and then there are a few other specific things that we really enjoyed on top of GCP, like Dataflow, service-based shuffling, and BigTable's latency optimization using SSDs, and then BigQuery SQL performance improvement over time, then integration with Looker and BI. Those things have been super helpful as well.
Thank you, Chang, very much for joining us and sharing a lot of insight into how and why you built this ad serving platform on top of Google Cloud. That is so cool. I now understand a lot better how those ads show up on my screen, what it takes to build a very latency sensitive, high performance ads platform on Google Cloud, and maybe a little bit more about the immense power of some of these tools. If you liked what you saw, please like and subscribe and check out the playlist Architecting with Google Cloud for more videos like these. Thanks for joining us.